Hello there. In this video, we're going to look at doing some simulations in parallel. That is, your computer has multiple CPUs, and each of those CPUs have some number of CPU threads. And why we would want to do this is because with, first of all, simulations, we often like to run many trials with different pseudorandom number seeds to produce a probability distribution of outcomes that matches the uncertainty around the problem that we're actually trying to study. A single simulation is likely to be substantially different, but if you accumulate many of them, you can see a distribution of outcomes and calculate statistics from that. So let's get started with, first we need to import Q, and we're also going to import the multiprocessing library. Now, one of the things that's different between the multiprocessing library and the Q library is that the multiprocessing library is part of the standard library. That is, that if you have Python installed, generally speaking, that you should also have the multiprocessing library ready to go. Whereas Q, you're going to have to install on your own. Okay, so let's define a simulation network as we have done many times now. Arrival distributions, q.dists, exponential with a rate. In this case, we're just following the documentation example, which gives a rate of 0.2. And I'm just going to copy that over because I'm a little bit, one might say, efficient or lazy, depending on how you feel. And we're going to set the service distributions to also be an exponential, but with a rate of 0.1. And we'll set the number of servers in this case to be 3. Okay. Now, let's also set some parameters here that we're going to want. Max time that we're going to run simulations for. And we might want something of number of trials, let's say. And let's say we want to do 200 for the moment. Okay. So, as we've seen many times, we could go, q.seed and set a seed number, let's say 0 for the moment, and then define a simulation instance by passing in our network into a simulation constructor like this, and then running the simulation. And of course, there's different ways that you can run. The simulation here will do until maximum time, and we will pass in our max time constant for that parameter of how long we're simulating for. And then we might want to do something like grab some records, right? And so we can take our simulation object and go get all records. And then from there, we might calculate something that we're interested in from the records, like maybe the waiting time. So I might grab record.waiting time for record in records. And then maybe I want to take an average. And so I might have something like the sum of the weights that were made and then divide by the length. This is just our arithmetic mean, average weight. And we get this average of 3.5. Great. So are we completely going to stop there in terms of doing simulation studies? No, we should probably run this a bunch of times. And if you've seen some of the previous YouTube videos that I've shared on this topic, often we would create a loop. But the thing about if we say construct something like a for trial in range num trials, and then something like that. The thing about this is that it is going to run, what am I trying to say? This is only going to run one trial at a time, and that perhaps we want to run multiple trials simultaneously, either to complete more trials in a given amount of time, or for a given number of trials to complete it sooner. So how can we do that with multiprocessing? Well, the multiprocessing pool class that we're going to use, along with something called StarMap, requires that we define some kind of function that can be serialized. So we'll go and create a new function here, get mean weight, and we pass in a network. and we'll have to pass in a seed number. We'll pick a default, but you know, whatever is fine. And we'll say 100, 1,000 for a default maximum time. And then inside of here, inside of this function definition, we will tuck that inside there, and we will set this to seed so that we're using the same seed that's passed in. And so now with this, oh, actually one more thing we should probably do is get rid of this print statement and just return the average weight for this trial. Okay, so unless I made some typos, I think we're ready to get started with defining a script that will run our trials. Now here I'm adding this if dunder name equals the string of dunder main, and this has to do sometimes with getting the serialization of your function to work as expected. However, it is system dependent. Like, I actually don't need this in my current setup, but there are systems where you may need this, so just keep that in mind. So let's first of all construct a pool process manager, multiprocessing, and we'll grab this class pool, and for the number of processes here, I'm going to pick 10, but something, you can pick something appropriate to the number of CPU threads on your system. And we need to pass in a collection of arguments that will be passed into our get mean wait time when we're running our little trials, right? We want to run different seed numbers. We also are going to want to use the same network over and over again, and we are probably going to want the same max time. Often for this type of thing, you'll want the same maximum time, though not necessarily. Depends on what you're going to do with the results, how you're going to analyze things. So let's create a tuple, and it does need to be, I think, tuple or similar things that can be yeah, I think it's just tuple. I'd have to double check that, but we're going to pass in network because we're going to pass in the same corresponding arguments that we'd pass into this function, get mean weight, that we're going to serialize. So we'll put in yes, seed and the max time. Actually, for us, this is our constant max time. And truth be told, we should probably use max time as this argument here just to stay consistent with the documentation. Okay, for seed in range of, and for us, we called this num trials. Reindent that back where it should be. Maybe let's review what we just did here. So we're creating this list comprehension where we're going to pass in a different set of commandos of using our network, passing in different seeds, and the same maximum time. Now, to actually do the call that does the running of all these simulations and returns the results we want, we then need to use a method, and I like using the star map that will unpack these tuples and pass them into the function. There is also a map function, but I think its constraints are a little bit different. Maybe only allows for one input or something like that. To have to double check. So let's get our average waiting times, and we'll use the same pool instance that we defined above. And in it, we will pass our get mean weight, the function that we are going to serialize and run over and over. And we'll pass in our args, which will get unpacked for us. So then let's print our average of the averages, sum of weights, and we can actually pass in just the num trials because this is the same as the sample size. Yep, that's fine. Good. So let's run Python multiprocessing example, and there's our averages of our waiting times. Now, this is one of those things where I would actually suggest that often you would want to pool these results differently, and maybe I'll do that in another video. It's not technically incorrect to take the average of a collection of averages, but it does change whatever question it is you're answering, or it depends on the question you're trying to answer, I should more appropriately say. So that's one thing to watch out for. I think often what I would suggest is to maybe don't take the average of the averages, but plot something like the distribution of these averages to understand what might be going on there. Anyway, hopefully that's useful. Hopefully that helps you speed up getting simulations done in a reasonable amount of time, or for whatever time you've got of expanding the number of simulations that you can do. And with that, good luck. I will see you in the next video. Take care.